Hey, we have here another integral. This one's from UNSW Integration Bee 2019, problem 21. We have this integral from -2 to 2 with a whole bunch of absolute values in it. And initially I was thinking I would skip this problem because it's pretty straightforward, but there's quite a bit of work to it. There's just a lot of steps simplifying the absolute value. But I thought I'd do this one anyway, just because I think the absolute value is kind of interesting. So let's see if we can work through it and try to keep it from going too long. Okay, so we'll start with this over here on the right. We have the definition of the absolute value, and this is really the key to the whole problem, just breaking it up into cases, because we know if we just have the absolute value of x, which that's exactly what we have right here. For the absolute value of x, if x is greater than or equal to 0, we just are taking back x. If x is negative, less than 0, then we're bringing back the minus of it. So we're just going to apply it a little differently when we have these other terms, but basically this is going to be the key to the whole problem right here. So it's just with the definition we've evaluated this first piece, but we actually have 5 different terms. And what I want to do is just do this with all 5 of those and see how this is going to go. So first we're looking at absolute value of x minus 2. We're saying this is going to be equal to x minus 2 as long as x minus 2 is greater than or equal to 0. Well, that happens when x is greater than or equal to 2. And then we're going to have the negative of this, which is just going to be 2 minus x, and that's going to happen when x is less than 2. Then we'll do like the same thing on x plus 2, okay? We're gonna just take back x plus 2 when x plus 2 is greater than or equal to 0, which is gonna happen when x is greater than or equal to minus 2. And then again, we're gonna have the negative of this, so I guess minus x minus 2 when x is less than minus 2. Okay, now I just continue, I did the exact same thing with our x in the denominator, x to the minus 1 absolute value, and our x plus 1, we have our values there. Hopefully I didn't make any mistakes, so we fill out this whole table. Now, before I do anything, I think what I want to start with is these x minus 2 and x plus 2 terms. The thing with that is we can use our bounds, so we're only concerned with this integral between minus 2 and 2. Now you'll notice for x minus 2, we're only going to really be using the positive version when x is greater than 2, greater than or equal to, but really essentially all we need is this value right here. So I'm going to do, to simplify a little bit, we'll rewrite this, but for x minus 2, it's always going to be negative, so we are going to take the negative and call this pair 2 minus x. Then we're going to do like essentially the same thing on x plus 2. You notice we're using the positive version when x is greater than minus 2. What's going to happen for x plus 2 with these bounds, it's always going to be positive because we're starting at minus 2. So everything we put in there is positive, so we can just bring back x plus 2. But then when we do that, we notice we have 2 minus x plus 2. Our x's are going to cancel. We add the 2's, and we just have 4. So what I'm going to do is when I write this, I'm actually going to clean it up, and we're just going to write that whole piece as a 4. Okay, so we have this simplified with just a 4 now in the numerator, so that's going to help us a little bit. But we still have a bunch of different cases with all these different values. So what I'm going to do is we're going to need to break this up depending on where we are in this domain. So like let's just do the first piece. This is actually going to become 4 integrals. So for our first piece, we're going to integrate from minus 2 to minus 1. And then we can just go to this table over here and see what we need for values. Like x in this range between minus 2 and minus 1, it's always negative. So this is actually going to be a 4 minus x. Then for x minus 1, okay, we're always less than 1, so we're going to take back this definition right here and use a 1 minus x. And then for x plus 1, again, we're less than minus 1, so we're going to use minus x minus 1. And then just a little cleanup on this, you see the 1's are going to cancel, and we're just going to have a minus 2x here in the denominator. Okay, so now what I've done is I just did the same exact thing for all 4 of these integrals. Okay, so for like in each region, I just went into this table and got the value I need. I know this is pretty tedious, but see, now you're seeing why I had second thoughts about doing this one, because there's a lot of breaking this up into intervals. So for each of these 4 integrals, I just went to the table and took back the value I wanted based on what we have in this chart. And we'll do a little simplification. So this one right here, the x's are going to cancel, and we're just going to have a 2 in the denominator here, okay? Then similarly down here, the x's are going to cancel, and we're just going to have a 2 again. In this one, the 1's are going to cancel, and we're going to come back with 2x. Okay, and from here, we just have 4 pretty straightforward integrals. So we just need to integrate these, plug in our bounds, and finish this thing off. Okay, so just keep things moving. I did these 4 integrals. So we're adding up all these 4 integrals, and I've just integrated all of these over here on the right side. Again, pretty straightforward, either power rule or natural log. So not too much to discuss with these. So then we just need to evaluate each of these. Okay, now here we have the values for each of these integrals over here on the right. All we need to do to finish this off is we just need to add all this stuff together. Let's see if there's a quick way I can simplify this. So we have a 2ln2 and 2ln2. So we're gonna have 4ln2 here. We'll take this minus a half and cancel, this is a half here. We'll cancel that there. Then we're gonna have 2 is 4, 5, 6, minus a half, 5 and a halves, and that's gonna be the same thing as just 11 over 2. Okay, that's it. So yeah, I would say this is a pretty tedious calculation. I know I kind of skipped steps, but hopefully I showed everything so you guys can follow it. Thanks everyone for watching. Have a great day.